So we've got this diagram of a curve and we've got to figure out what the equation of the curve is. And the way into this one is the fact that we know we've got to find two variables, p and q. So if we've got to find two variables, it means we're going to need two equations. So we've got to figure out a way to get those two equations. What I'm going to do is use the intercepts. I'm going to use those two values to create an equation. So we know that that can be written in the form y equals x minus p, x minus 6. So that's the first thing. So that gives us y equals, let's multiply it out, x squared minus px minus 6x 6p. Right, a little bit of tidying up. Y equals x squared. I'm just going to tidy up those two terms there. So we've got minus p plus 6. So we've got minus p, minus plus 6 is the minus 6. So that's why the sign's changed there. Plus 6, x plus 6p. So that's the first thing. Next thing I'm going to do is use that piece of information to write an equation regarding q. So we're going to use completed square for that one. So it's a minimum point, so we know we've got y is going to equal x minus q all squared. So that gives us the x coordinate, so that's the kind of the first part of it, and then the minus q, and that's the second part of it. Now let's multiply that out, and we've got y equals x squared minus 2qx plus q squared minus q, which looks like a whole load of x's, q's and p's and all the rest of it, but you'll see in a second how we're going to deal with all of that. So now what we've got, if we just shift all that up, is we've got our equation y equals, and we've got it in terms of two different formats. So we know that this thing up here has got to be exactly the same as that thing there. And what that means is if we have a look at that thing there, which is our x coefficient, that's got to be the same as that thing. And those two things have to be equal. So we know that minus p plus 6 has got to be the same as minus 2q. Let's just get rid of the minuses. So we've got p plus 6 equals 2q. And what we've done now is formed an equation that links p and q together. By the same token, the constant term on the end, so in this equation it's the 6p there, that's got to be the same as the constant term in our other equation, which is down here, which is going to be those bits there. They're the bits that don't involve x. So from there we've got 6p has got to be the same as q squared minus q. And so now you can see what we've done is form a simultaneous equation. What I'm going to do is just do a bit of rearranging over here. So we've got p equals 2q minus 6. And then we can stick that into our other equation. So we've got 6, and then we've got the p, which is the 2q minus 6. And that equals q squared minus q. And now what we've got is an equation just in terms of q that we're going to be able to solve. So let's do that solving now. So let's do some multiplying out. So we've got that 12q minus 36 equals q squared minus q. It's a quadratic. Let's get it equal to 0. So we've got q squared minus 13q plus 36. Let's do some solving. I think that'll factorize. Let's have a look. So, yep, 9 and 4 minus, that gives me q equals 9 or q equals 4. Now we've got two possible values of q, but if we go back and have a look at our diagram, there it is, we can see that on our diagram the value of q has got to be less than 6. So what that means is for my two values, the one we're actually interested in is that one there. We can ignore that one. So we've got q equals 4. What we've got to do is go back to find the value of p, and we had that p equals 2q minus 6. So therefore if q equals 4, p equals 2 times by 4 minus 6, which leads us to p is 2. And there we go, we've got our two values. We've been asked to find q and p. Q was 4, p is 2, and there's the whole thing done.